is Monday, December 2nd. Back to using the antiderivative, integral, area type stuff. Okay, so you know what? Let's back up even a step from here. Let's just come up to the top of the page here. And we answered this question 3 or 4 different times. It showed up on the test. I think everybody got it right on the test. Sort of a freebie, but that's fine because it comes up again here. The antiderivative of the derivative of f. What's this equal to? F of x plus c. Because the antiderivative of the derivative gets us back to the original. Like, good. We got that one. We killed that one over and over again. Today we're going to tweak that a little bit, and we're going to put an a and a b on there. So instead of an indefinite integral, this is a definite integral, just because it has the limits there. Definite integral because of the a and the b. But it's that same thought process. The antiderivative of the derivative of f gets me back to f, but now I need to plug in the top minus plug in the bottom. So that thought process of the antiderivative undoes the derivative. That's what the fundamental theorem of calculus is. It's like, wow, we're halfway through the year, and this thing sounds so complicated, it's so fundamental, and basically it's that the underderivative of the derivative gets you back to the original. Like, yeah, what's so complicated about that? The antiderivative of the derivative gets us back to the original. If it's indefinite, we got to throw the plus c on there. If there's limits, we do top minus bottom. Okay, so no big deal. How we're going to use that, that's the fundamental theorem. The application, then, is that this f of b minus f of a is the change in f from a to b. F of b minus f of a. It's like, well, that's not really that big a deal either. If we take an antiderivative of the derivative, we get back to the original. And so I guess what we want you to realize is that this antiderivative of a derivative gives you the change in the original. So be careful. It gets you back to the original, but because of those limits, it gets you the change in the original from a to b. I think this is easier in practice than it is in theory. If you know an expression for the rate of change of function, so that would be f prime, rate of change of a function, and a value of the function, you can get any other value of the function you like. Again, easier to do than to talk about, I think. Let's do number 1. If f prime equals 5x to the 4th plus 10x, f of 1 equals 3, find f of 2. Okay, so be very careful, always be very careful about what they give you. Just like when we were doing graphs a while back. Like, be super careful about what you're looking at. F prime, they give me f prime, and they're asking questions about f. So what am I going to have to do to f prime to get to information about f? Antiderivative. I need to undo the derivative. So let's antiderivative the derivative. That would get me back to f stuff. And I've got values here, so top minus bottom. Now, what values of x do you think I should use for my limits? Where'd 1 and 2 come from? I agree with you. Well, yeah, those are the x values that we have, so let's use 1 and 2. because those are the x values that we are given in this problem. And it's always the evaluate at the top minus evaluate at the bottom. Okay, so let's start filling things in here. Antiderivative from 1 to 2 of 5x to the 4th plus 10x equals f of 2, that's what we're trying to find, so we don't know f of 2. F of 1, we know, they told us that's 3, so we'll plug in 3 there. So now all that's left for me to do is this stuff on the left-hand side. So I need to antiderivative 5x to the 4th and antiderivative 10x. Let's see, so that'd be x to the 5th plus 5x squared from 1 to 2. I'm probably going to like kind of off to the side figure out what this is and then go back to this equation. That's a good question. Why do I not have a plus c on this particular problem? Because it's definite. There's limits there. You good there? By the way, if you included a plus c, eventually it'll go away. Because if you plug in the 2 minus plug in the 1 and you have c, both of those, you're going to have c minus c, they'll cancel each other out. So it wouldn't be wrong if you put it in there, but eventually it's going to go away. Alright, 2 to the 5th plus 5 times 4 minus 1 to the 5th plus 5 times 1. So I'm just cleaning all this up and then we'll go back to the equation in a minute. 2 to the 5th is 32. 5 times 4 is 20. Minus 1 plus 5 is 6. And I mean, you could safe stop this at somewhere along the way, but I mean, you'd have to plug all of that in for this integral, so you may as well clean it up. 52 minus 6 is 46. So all of this, that integral, is 46. That equals f of 2 minus 3. So the big picture was understanding the antiderivative of a derivative gets us back to the original. We had to take a little detour to figure out the antiderivative, but now we're back to plugging things in that we know. So if I add 3 to both sides, f of 2 is 49. Number 2, we'll need a calculator, but let's don't grab the calculator yet. Let's get this thing set up, and then we'll go grab the calculator and have some real fun with this. Sorry. Okay, if g prime equals this ugly thing, g of 5 equals 2, find g of 1. They gave me g prime. They're asking questions about g. So what do I have to do to g prime to get back to g? Antiderivative. I need to underderivative that prime off of there to get to g stuff. So I need the antiderivative of g prime. And that will get me back to g stuff. Again, we'll grab the calculator in a minute. Amber, what do you think we should use for our limits? 5 and 1, because those are the... It would almost be better to plug them in here first, because that's the things we know and are looking for, which means we need those as our limits. So antiderivative from 1 to 5, e to the negative sine x dx equals g of 5 we know, g of 1 we don't know, don't really want to grab the calculator yet. Let's solve for g of 1, and then we'll go to the calculator. So I'm going to move g of 1 to the left-hand side and move this integral thing to the other side, subtract it over. On the last problem, I was able to evaluate this integral without a calculator. This one says I'm able to use a calculator. So let's grab a calculator and see if we can figure out how to make the calculator do that. So I'm going to press pause. Okay, Math 9. And if you've got the latest operating system, which most of them are, but some of them aren't, if you have the latest operating system, it puts it like that, and so it's easy to know where stuff goes. If you picked F9 or you picked Math 9 and it just says FNINT with the open parentheses, you could learn how to put it in, but you'd probably be better to just grab a different calculator. Is that what you got, Ben? Can I see that calculator, though? Just so people know what they're looking at and know what to do if this happens. Again, if this happens, it's probably best to just grab a different calculator. Math 9. If it says function integration, like there's a way to put it in, but don't do that. Like just say, you know what, let's grab a calculator that looks nice. So there's a few that are ugly like that. Grab a different one. Okay, 1 to 5. E to the negative sine of x. Oops. Dx. Be careful, though. That's not my answer. I mean, it's not the answer to the question. Like that's this part. I need to do 2 minus that. So just don't get so excited that you found the calculator buttons and the calculator does all the hard work that you forget like the rest of the problem. So 2 minus that. My answer is negative 2.970. Always 3 decimal places. Math 9. Amazing. Always 3 decimal places. Number 3, with calculator. Worded a little bit differently, but let h of x be an antiderivative of. So it means if I take the antiderivative of this thing, I get back to h. So the antiderivative of x to the 4th plus cosine x over x cubed plus 2. That's why we have a calculator, because I don't think anyone knows. I don't think that can be done. Equals. Okay, what gets me back to. Okay, it's not here. Jimmy, what x values should I use? What limits should I use? Yeah, 3 and 7, because that's the values that we're worried about here. So 3 to 7. H of 7 minus h of 3. We know h of 7. Don't know h of 3. So h of 3, you're going to have to rearrange some things. Why don't you see if you can finish this problem out? Okay, good question is this a safe stop? Because it is calculator ready if your calculator knows calculus. But it needs to be calculator ready for a non-calculus calculator. Like, you can't leave calculus to go in a calculus question. Does that make sense? I mean, you're right. If I phrase it as calculator ready and you're saying I can put that in my TA84 exactly like that, then you're right. That's calculator ready. But we mean calculator ready, but without your calculator doing the calculus. Negative 16.472. Once we type it in. Number 4. I think number 4 is easier than all the others. It's telling me the antiderivative of f prime is negative 1.6. I want to find f of 9. They picked the right limits for me, 2 and 9. So let's sort of write this a different way. The integral from 2 to 9 of f prime. Yes, that's negative 1.6, but that's also antiderivative of f prime gets me back to f of 9 minus f of 2. So they told me that, okay, so this is like easier than the ones we've done before. Previously, we evaluated the integral by hand, and then we used the calculator, and now they're just going to tell you that's equal to negative 1.6. F of 9 I don't know, f of 2 is 3. So if I add 3 to both sides, I get 1.4. But it feels like they give you so much information, they make it complicated. Number 5, the graph of G prime, a graph problem. The graph of G prime, look, that's G prime, consisting of 2 line segments and a semicircle is shown on the right. If G of 3 equals 7, find G of 0. Okay, they're asking us for G. They're giving us information about G prime. How do I get from G prime back to G? Underivative. So I need to underderivative G prime. Autumn, what limits should I use? 3 and 0, because those are the x values that are like involved in the problem. So 0 to 3. That would be G of 3 minus G of 0. G of 3 they gave us, G of 0 we're looking for. How am I going to evaluate the antiderivative of G prime? Area under the curve. So this is another way to do this. That's area from 0 to 3. So let's be careful. I don't want the whole area. I just want the area from 0 to 3. So let's see. 1/2 base times height would be 3/2. And then 1/4 of a circle. So 1/4 pi times radius is 2 equals G of 3 I know. G of 0 is what I'm looking for. Is this a safe stop? I need to solve for G of 0. Like, I don't have to do any of the adding or even the 4th and 4, but I do need to get G of 0 by itself. So I'm going to add G of 0 over and subtract the other stuff. So 7 minus 3/2 minus pi. Is that a safe stop? Yeah, there's no calculus left. That's just a scientific calculator could do that for me. So I'm just going to leave it like that. Number 6. This looks pretty similar because I've got a graph of G prime and they're asking about G. So I'm almost certainly going to have to underderivative, antiderive G prime to get stuff about G. Let's see. For this particular one, I want -2 and 1. So negative 2 to 1, top one minus bottom one. Antiderivative of the derivative gets me back to g. Evaluating antiderivatives, I can either do it by hand, I can do it by calculator, I can do it by area, or they could just give it to me. There's like 4 different ways to find this. Obviously, this is an area problem. And I want the area from negative 2 to 1. So negative 2 to 1. Should be careful coloring in because I've got 2 more problems that will require probably different areas. So the area from negative 2 to 1, that's just 3/2. G of 1 is 5. G of negative 2 is what we're looking for. A little bit of algebra to move some things around. So G of negative 2 equals 5 minus 3/2. That's an okay safe stop. Kind of a weird answer maybe, but an okay safe stop. 5 minus 1.5 would be 3.5. Part B, find G of 5. So what limits should I use for part B? Definitely 5. And I would use 1. I guess you could use negative 2 since you know the value there now, but we definitely know 1, so I'm probably going to go 1 and 5. So now I'll find the area from 1 to 5. That's not bad. What do you notice about the area from 1 to 5, though? It's under the x-axis. So what does that mean? It's going to be negative. So G of 5, if I add 5 over, is 5 minus 2 pi. G of 6. What limits would you like to use to find G of 6? Obviously 6 needs to be one of them. What do you want the lower limit to be? You kind of have options here. So I think I would go with 5 because I know G of 5 now. So it's going to make my life a little easier if I'll go 5 to 6. Because then my area is easier to work with. I just want the area from 5 to 6. So that area, that's just 1. G of 6 is what we're looking for. Minus, I guess this is where it gets maybe complicated. G of 5 is 5 minus 2 pi. So G of 6 then is 1 plus 5 is 4. And then minus minus is plus 2 pi, but then I move it over, I get minus 2 pi. G of 6, don't know. G of 5 is 5 minus 2 pi. Yep, you're right. I was like, wait a minute, this does not look right. If I move the 5 over, I add the 5 over and get 6. There we go. 1 plus 5 is 6. Yes. Got my 2 pi's right, I just couldn't do 1 plus 5. Okay, this next question looks complicated, but if we justify first, it'll make life a lot easier. Find the value of x at which g has a relative max. G has a relative max. Let's justify first. So forget about this particular problem. Just in general, how do you know when g has a relative max? What's happening? G prime would be changing positive to negative. That's always true. Like that's G has a relative max if G prime changes positive to negative. So that's true. Okay, well I have a graph of G prime. So now I'm just looking at my picture. Where does my graph change from positive to negative? At x equals 1. So it maybe seemed complicated, but if you justify first, not a big deal. Same thing for part E. Find the values of x at which g has a relative minimum. Well, let's answer the justify first so we know what to look for. G has a relative minimum. And again, I don't have this stuff memorized. I think about it every time. I do my little hand motions every time. G has a minimum when we're going when G prime changes from negative to positive. Yeah. So now I look at my picture. My picture is G prime. Where does it change from negative to positive? At 5. Ooh, point of inflection. Point of inflection would be, tell me something about point of inflection of G. Without worrying about this graph, just in general, what does point of inflection mean? G double prime changes signs. So don't get too complicated yet. G double prime changes signs. That's right. That's always a point of inflection. I guess the trouble is I don't have a graph of G double prime, so I need to reword this in terms of the graph I have. So what about G prime tells me G double prime? So I want the slope of G prime to change signs. Because G double prime is the slope of G prime. Those are the same thing. But I need to I have to answer the question in terms of the information I have. So saying something about G double prime it's not wrong, it's just not helpful yet. So where does the slope of G prime change signs? Uh-oh, many different answers here. Where does the slope of that graph change signs? Negative, 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 negative. So it did not change at 1. The slope didn't change. It changes at 3. The slope of that graph changes at 3. Absolute max, absolute min. When you see the words absolute with max and min, you're supposed to make sure you think of what? Absolute means don't forget to check the endpoints. Okay, so let's just make a table of values here. So I definitely want to check the endpoints, negative 2 and 6. And the critical points we already found, 1 and 5. Endpoint, critical points. Because they already asked me about relative mins and maxes. And I think we already have a bunch of these values. I'm looking back up We found g of negative 2. That was 3.5. G of 1 they just gave to us. That's 5. G of 5 we found. And g of 6 we found. Okay, I guess now the trick is 5 minus 2 pi and 6 minus 2 pi. Well, which one's the max? I think the max is easy. Well, be careful. The max is this set, but which value is the max? The 5 is the max. It occurs at 1. So the max is 5. It occurs at x equals 1. I did not ask for that, so we don't have to say that. Just putting it on there to kind of highlight the fact that that's where it, be careful about where it happens versus what it is. The minimum, which one of those is the smallest value?
Isn't pi just like basically 3?
Pi is 3-ish
So,
for our purposes. So 5 minus 6 versus 6 minus 6, which is smaller?
yes.
Ben, I heard you say 6 minus 2 pi. But the answer is 5 minus 2 pi. It happens at x equals 5, but that's not the question. Okay, goodness, that's a lot of stuff in there. Today's assignment is Unit 8, Worksheet 2. Calculator is required for some. A lot of theory, not a lot of work on some of these, really. Like computationally, it's an easy day. Theory-wise, it's a harder day.